Hello everyone. Today we'll be doing another session on binomial theorem. We'll be continuing our discussion on binomial theorem. So in our previous video we talked basically about, in our previous videos we talked about what is binomial theorem, how we expand in a binomial theorem, talked about some properties of it, and we also talked about the various expansions of x plus a to the power n, x minus a whole to the power n, 1 plus x whole to the power n, 1 minus x whole to the power n. These are the expansions that we look forward to. And we did this, and in our last video we basically did a video on the middle term of the binomial expansion, so that was done. So today we'll be doing another video on a topic from the binomial theorem, which is basically we'll be talking about the greatest term in a binomial theorem. So the good way to learn about the greatest term in a binomial theorem is basically we need to we can solve some examples, and we can take some examples, solve them, and you'll be having a better grip over the understanding of the greatest term of a binomial expansion. So let's begin. Suppose we have an expansion of the form. We have an expansion of the form. Let me think of an expansion of the form. So we can have basically, if we take an expansion of 1 plus x whole to the power 10, we need to find out the greatest term of this expansion when x is equal to 2 by 3. This is an example that I have picked out from a book. So let's start off with it. So now what happens? Let us find out the tr plus 1 term. So tr plus 1 term, what will be the tr plus 1 term? So this is basically the 1 plus r plus 1 term of this 1 plus x whole to the power 10. So this will be equal to 10 cr into x to the power r. So very straightforward. So we have 10 cr into x to the power r. So this is the tr plus 1 term. And similarly, if we find out the r term, so this will be equal to 10 c r minus 1 into x to the power r minus 1. So this is the structure. Now if we divide these two things, if we divide t to the tr plus 1 by tr, so this will be equal to, on the numerator we'll be having 10 cr into x to the power r, and in the denominator we'll be having 10 cr minus 1 into x to the power r minus 1. So as you can see, if we solve the structure, this will give us, now 10 cr will be basically equal to 10 by r into 10 minus r, and this will give us factorial 10 into factorial r minus 1 into, we have 10 minus of r minus 1, and x to the power r and x to the power r will cancel out from the numerator and the denominator, and we'll be left out with just x in the numerator. So this is the structure. So as you can see over here, factorial 10 and factorial 10 will cancel out. Factorial r minus 1 will cancel out from factorial r, and we'll be left with 1 by r from here. And then we have 10 minus r, and then we have 10 minus r minus 1. So basically, as you can see over here, we'll be left with 10 minus r minus 1. So this will be the structure which will be remaining in the numerator, and then we have x as always. So this will basically give us, 11 minus r by r into x. So now as you already know that we have been given that x is equal to 2 by 3. So this will be equal to 11 minus r by r into 2 by 3. Now this is basically, now if we take, suppose if we take t r plus 1 by tr is greater than 1, if we take it this format, then this will be giving us 22 minus twice r upon multiplication by thrice r will be greater than 1. So that means that 22 minus twice r will be greater than thrice r, and upon solving this will give us that 5r will be less than 22, and we finally have that r is less than 22 by 5, which is equal to, if we take it in a partial fraction way, this will be equal to 4 2 by 5. So r has to be less than 4 2 by 5, and in that case we'll have that tr plus 1 will be greater than tr. So since here it is a fractional value over here and r is less than this fractional value, so this will ultimately give us that r must be equal to 4. So r equal to 4 is the greatest. R equal to 4, that is we have, if we have the, basically if we have the t4 plus 1, that is the t fifth term, that the fifth term is the greatest. And what is the fifth term in this case? So that is what we need to find out, the fifth term over here. So here the fifth term will be equal to, let me rub it out. So we had the expansion of 1 plus x into 10, so the t fifth term will be equal to, basically we have 10c4, we have 10c4 into x to the power 4. So this will be equal to 10c4 will be basically 10 into 9 into 8 into 7, and then you have 4 into 3 into 2 into 1, and then you have 2 by 3 to the power 4. So 2 to the power 4 by 3 to the power 4. So as you can see over here, if we cancel it out, 4 and 2, this will cancel out 8, and then we have, so we have basically 3 to the power 5 and we have 3 squared. So this will be equal to 10 into 7, 3 squared by 3 to the power 5, we have 3 cubed. So we have 70 by, we have 3 into 3, 9, 9 into 3, we have 27. So 70 by 27 is the greatest term that we're looking forward in this case. So this is how you solve the greatest term number related problems on the binomial theorem. So this is the way. So if you have any doubt regarding this sum or in any sum in general from binomial theorem or from the greatest terms topic, so you can comment in the comment section below and we'll try to get back to you. Thank you very much.